Okay, we're trying some more examples of inverse trigonometric functions. Now we're asked to identify the domain and range of the arc cosine function and graph the function. So let me start by graphing the cosine function itself. So there's pi over 2, pi, negative pi over 2, 3 pi over 2, 2 pi. So what I just graphed there is just cosine theta. I didn't graph the arc cosine function yet. And the key thing here is we're going to flip this function around, the y equals x line. So we're going to flip it around the line y equals x. And we want it to be a function after we flip it. And right now, if we flip it the way it is, then it won't be a function because it won't pass the vertical line test. So we need to cut off just a little piece of the cosine function and flip that little piece around, and that'll give us the arc cosine function. So what we're going to do is we're going to cut off the piece from here at 0 to here at pi. So we're going to cut off this piece. We're going to cut here to make arc cosine function. And the point of doing it like that is if we cut it off that way, we'll get something that'll pass the vertical line test after we flip it. So let me draw that now. Let me draw what we get when we flip it. If we just take that little piece that we cut off, it started at 0, 1. So let me start this one at 1, 0. It went down to pi over 2, 0. So I'll run it up to 0 pi over 2. And then it went to pi negative 1. So there's pi on the y-axis now and negative 1 on the x-axis. And that is our graph of arc cosine x. Now the domain is all the numbers you can plug into that. So it's all x with negative 1 less than or equal to x less than or equal to 1. The way you know that is it's all the numbers that can come out of the cosine function. Cosine always gives you numbers between negative 1 and 1, so those are the numbers that you can plug into arc cosine. And let me emphasize here that the endpoints, negative 1 and 1, are included. Those are less than or equal to signs. Back when we studied the arctangent function, we had to leave the endpoints out, negative pi over 2 and pi over 2 for arctangent. We left those points out because the function never actually got to those points. Here we include negative 1 and 1 because the function does get to those points. The range is all y with 0 less than y less than or equal to pi. 0 less than or equal to y less than or equal to pi. It's all the y values that you can get from the arc cosine function, which in turn corresponds to all the values that go into this little piece of the cosine function. So it's all the values from 0 to pi. So we've identified the domain and range, and we've got ourselves a graph, so we're done with that example.